All right, today's lesson, we're going to talk about the medians of a triangle. We're going to prove that the medians of any triangle intersect at a single point. Let's consider the definition of a median. A median is a straight line drawn from any vertex of a triangle to the midpoint of the opposite side. So for example, here's the vertex, and this is considered the midpoint if it's a median. And these two sides are congruent. If you have two medians, this will be considered a midpoint. And so with this, we're trying to show that all three medians of a triangle intersect at one point. So for now, we know this much. What we're going to attempt to do is to construct a parallelogram. Consider these two medians, and let's call this midpoint K and this midpoint J. Let's construct a segment and call it KJ. From the previous theorem, we know that KJ is parallel to the third side because KJ is a segment that intersects at the midpoint of this triangle. So we know these two are parallel. And what we're going to do is construct a third line that's parallel to the third side and KJ. Let's call this segment HI. And what we're going to do is we're going to connect the sides, these two, the midpoint to this, to point H, and form a parallelogram. All right, by the definition of a parallelogram, we know that the diagonals, which is JH and KI, intersect each other. So, the definition of a parallelogram, we know the diagonals intersect. And if you construct this median and make it a perpendicular bisector, we know that it's going to cross through the center. It's going to cut through half of this triangle, so it has to cut through the center. Therefore, we have proven that all three medians intersect at one common point in the triangle. This concludes the lesson for today.